Now, wastewater submersible pumps, gentlemen, when we try to make selection, usually we select it in the same way how we are doing with the normal water. I mean, as a curves, the duty point, all these steps, it's the same. But there is something we need to take a look on it, that the submersible pumps actually, they are not one thing. There is one criteria we have to consider during selecting a submersible pumps, which is the type of wastewater, because wastewater, it's very general term. Wastewater, it's a very general, and this waste can be differentiated. So each type of submersible pumps actually is designed for a specific, or let me say, kind of wastewater. And this is very important to consider. Now, wastewater, that could be effluent water, or we can call it gray water. There is the drainage, there is stormwater, there is sewage, and there is slurry or sludge. For example, if we talk about sludge, I cannot, for example, use a pump for drainage to pump sludge. Now, once we say effluent, this is a water, let me say, it's not clean, but it's almost to be clean. There is some dust, some small particles of soil or sand, and it's not in big quantity, it's very little. This is what we call effluent water. And usually these kind of submersible pumps generally could have strainer in bottom, but with smaller holes. This is not for effluent, but I'm just trying to give you an imagination. Okay, so if the pump is for effluent, it has to be used for effluent. I cannot use it for sewage. Now, effluent, we are talking about the particles inside, could be 8 millimeters, 7 millimeters, maybe 9 meters. It's very small things. This is the biggest particle that can go inside the pump and be pumped out. Okay, so this is effluent. There is type of submersible pumps for wastewater is for drainage. Now, frankly speaking, this is the most term that makes confusion, because many of manufacturers, once they say drainage, they don't mean the sewage. Once they say drainage, they mean actually the water that comes from the sinks, from lavatories, bathtubs, bodies, you know. So this is what they call it, drainage. But the water which comes from closets or kitchen sinks, these are the sewage. Okay, the flow, the liquid which comes from closets and kitchen sinks, those are the sewage. The rest of the things are drainage. Now, so the pump which is designed for drainage, we can use it with this kind of waters which I said, or for the rainwater which is gathered in some buildings, for such kind of applications. But also I have to notice and give a remark that some pumps could be written on the catalog, it's drainage, but actually it can also pump a sewage. I mean, just to clarify this, that some manufacturers, when they say drainage, they don't mean the sewage, but the others, there is some others, when they say drainage, they mean including the sewage. How can I know? I can go and read inside the catalog what exactly type of liquids this pump can do, or pump. This can you know it easily from the supplier, and frankly speaking, it's better to read it from the catalog or ask the manufacturer. So, drainage and sewage. Now, stormwater, actually, stormwater is close to the drainage. But stormwater, because this kind of water, maybe there could be sand, stones, something more solid, cruiser. So this kind of pumps could be the same like the sewage or drainage, but usually we focus the impeller to be stainless steel, okay? Because for sewage, we usually go with cast iron impeller or ductile iron, even with the drainage. This is the most common because they are very suitable for these kind of liquids. But for stormwater, no, we can go for the hard iron, or we can go with stainless steel material, I mean, for the impeller. This is like something exceptional for the stormwater. Why? Because the impact of the sudden, or resistance for impact for sudden hitting becomes more critical for stormwater applications. Slurry and sludge is different than all above. Why? All these liquids above the first one, the water content is the biggest. I mean, these kind of liquids, the water content is the major, okay? And the solids are the minor. But in slurry and sludge, actually, it's a clay in a water. So the water content could be half or around, but it's not the major, okay? So to pump this kind of liquids, make sure the pump is designed to pump sludge, okay? So this criteria, again, the type of wastewater has to be included in your selection process when you try to make pump sizing. Now, as you can see in these photos, which is in front of you, you can see 6 types of different submersible pumps: stainless steel, cast iron, with float switch or without. For example, also this is a remark. Sometimes people, they ask for submersible pump with a float switch. This could be, you could have it if the pump is single phase, okay, single phase. But 3-phase, we cannot have a 3-phase submersible pump with a float switch, okay? Then, if you need a float switch for dry run, which is a must, which is important, this you need a control panel, and this float switch can be connected to the control panel. But for single phase, no, this float switch could be like in series with the power supply, so you can protect the pump even if you don't have the control panel from dry running, okay? Sometimes you can see some pumps with something we call it a grinder. This is what we will talk about. Sometimes it has a strainer. the strainer, because the pump is not designed to pump big particles. So this is why they put a strainer. Now, let us take a look on the types of wastewater submersible pump, but from the design perspective. My friends, there is two general categories of submersible pumps. These two categories, they are totally different in their strategy to pump this wastewater. It's completely different. The first type or first group of submersible pumps is the free passage, which follows the free passage principle. What do we mean by the free passage? We mean that these kind of submersible pumps, they took the water with the dirt in it, with the solids, with all impurities, and they pump it as it is. Okay? This is the free passage. They pump the water with the dirt, with the solids as they are. They took it from there, they pump it out. That's it. This is the free passage principle. But the other category of wastewater submersible pumps are grinding or cutting pumps. The philosophy which they follow, these kind of submersible pumps, they cut or grind the particles, the solids, to make it more fine. Then they will pump the water with these fine particles. So this is like two different principles in how we are pumping the wastewater. Now, let's go back to the free passage. The free passage submersible pumps, there are two major types that belong to free passage philosophy, which is the non-clog and vortex. Now, these non-clog and vortex, these are two types of submersible pumps who belong to free passage concept. The non-clog submersible pumps, this kind of submersible pumps, if we can see here, you can see the blue, which is in blue color, this is the casing, and the yellow, this is the impeller. You can see the impeller is a closed type, but the distance between the two shrouds is wide. You can see here, the water, the waste goes inside from here, then it's pumped out from there. This is this is like general type or general shape of this impeller. So I can say this is submersible pumps. So the water will be sucked from here, and this impeller rotates very fast. So there is inside one vein or two or three. This vein or the multi-veins will force the liquid to rotate and to be pumped out. Why we call it non-clog? Because it's resistant for clogging. Why? Because the impeller is wide. It has bigger passage for these particles. So mostly there will be no clogging. Okay, it's not easy for clogging to be happen. Okay, so this is the non-clog principle. The non-clog submersible pumps can reach the highest level of efficiency compared to other types of submersible pumps. Now, the second type of free passage pumps, which is the vortex. If you see the pump here, you see the casing, the blue one, Look, the impeller, the yellow part, look how it is so far from the inlet. There is a big gap between the inlet and the impeller. The type of impeller here is a semi-open impeller. This impeller, when it rotates, it creates a motion like a vortex in the water. So the water will go inside, but it will rotate, creating a vortex. This vortex actually keeps the water holding these solids with it. So the water will take all particles with it, and once goes inside the pump, it will go to out. So actually, the impeller is not much touching that particles. The impeller actually makes like influence from a far distance, you know, trying to make some far influence on the liquid to make the pumping. Now, the vortex pumps actually is better than non-clog in the manner of risk of clogging, which means, let me clarify it better. The vortex there is less chance for clogging to happen compared for the non-clog pump. Why? Because you have very clear passage, big passage, and you are depending on the vortex in pumping. So the possibility for clogging to happen is very almost, there is no risk. Non-clog, there is some possibility, but non-clog has higher efficiency than the vortex. Vortex pumps, because of this type of design, generally the efficiency is low, 20 to 40%. Non-clog, no, can exceed 60%. So non-clog pumps give you higher efficiency than vortex, but vortex is more safe from clogging. Now, both types, non-clog and vortex, they have different sizes, okay? But also, how we can know the volume of the particles that they can pump. For example, if you brought me a pump and you said this is non-clog pump, okay, but does that mean they can pump a ball, has for example a baseball ball or golf ball, or smaller particles or bigger? How much? How can I know? Simply, you can ask or read it in the catalogs. You will go and see something, they call it particle size. For example, the manufacturer will tell you our pump has a particle size 50 millimeters. He means this ball, if for example, this is the pump. If you are pumping solids, spherical solids, for example, spherical solids has a diameter of 5 centimeters. These solids can go through the pump and be pumped out successfully. If it's bigger than that, the pump cannot pump it, cannot suck it and deliver it. So particle size, once we say 50 millimeters, means these solids which comes with the water, if it has a dimension of 5 centimeters, can be pumped, but not more than that. There is pumps 50 millimeters, there is 70, 60, 80, 100, 150 millimeters. There is, but be careful. Once you decide to have particle size bigger, you should expect the pump also will be bigger, because the inlet and the outlet also has to be bigger. I mean, for example, I cannot request for submersible pump discharge 2 inches and to expect it can pump 60 or 70 millimeter particle size. It cannot be. Now, once we say particle size, gentlemen, we mean solids. Why? Because sometimes, for example, if I said towel, if I have a towel is a solid, but this shape can be modified, right? Because it's something flexible. So these pumps can pump towels without any problem. Okay, why? Because the towel itself, it doesn't have a fixed shape. But once we talk about particle size, we are talking about this solids which has a fixed shape, like stones and balls. So particle size, again, it's an indicator for you to imagine how big the solids can be pumped by your pump. Now, generally, the sewage particle size of 50 millimeter, any liquid has particles of 50 millimeter is considered a sewage. Okay, it's considered a sewage. 35 millimeter is considered drainage. Below 10 millimeter is considered effluent. Okay, so this is again the concept of particle size, which is exclusive for the free passage pumps, which are mainly the main categories, non-clog and vortex. Now let's go to the other family. The second family, which is the family of grinding or cutting. The major two types of these pumps are submersible pumps with grinder. This is a type. And there is something we call it cutter impeller. They are not the same. Yes, both of them, they have the same strategy by cutting the solids, then pumping it. But what's the difference? First type, which is the submersible pumps with grinder, this kind of pumps, if you see prior the inlet, if we look from bottom, we will see this. This is the bottom view of the same pump. You can see prior the inlet, there is a knife here, cutting edges. This rotates because it's connected to the shaft. So once the pump rotates, it rotates very fast. So any particle solids will be pumped, will be grinded by this knife or edges. Behind these edges, there is a screening holes, which will not allow for the big parts to go inside. It will allow only these grinded particles to go in. So the water with the grinded particles, then it will be pumped. So this is a submersible pump, is equipped with an external grinder. The cutter impeller type, with this, which is the second one, here the concept is different. This kind of pumps, actually, they are not grinding. They cannot make fine particles, but they are like cutters. But who's making the cutter? We don't have a grinder here. The impeller itself is the one who is cutting these solids. If you can see here, we see the pump from bottom, and we opened the lower part of the casing. This is the lower part of the casing. This is the lower part of the casing. And this is the internal surface of this part, which means once you mount this on here, this will be inside in front of the impeller. Now, look to the impeller. The impeller here is semi-open, and you can see here like two veins, but they are wide veins. Once the pump sucks the water, it goes from here and entering here. Then these veins will force the solids to be like it will press it on this surface, and you can see in this surface there is some grooves. There is very sharp grooves. So the impeller actually presses the particles on these grooves, so it will be cut. So you can make these particles more smaller, then the same impeller will pump them out. So as you can see, cutter impeller. So you can see mainly who's the cutting here is the impeller. That's the difference between these two types. Now, usually, again, as a general view, the non-clog has the biggest efficiency among all types. Now, if I want to pump various particles and without any risk of clogging, you can go with the vortex. It's more safer, but the efficiency will be lower. If your liquid contains spongy material or hair or grass, this kind of particles is not suitable with the vortex pumps. Then it's better to go with the non-clog. Okay, grinder. Some people believe that the submersible pump for sewage must have a grinder or cutting part. And this is false. It's not a must. Why? Because non-clog and vortex are also designed for wastewater, and they are very good in that. But once if your pipes for the sewage is less than 2 inches in internal diameter, less than 2 inches, then it's better to go with the grinder. Why? Because non-clog or vortex pump, they can pump particles, big sizes, to the pipes. If your pipes are 3 inches, 4 inches, we are okay with that. But if the pipe is less than 2 inches from inside, then these particles, maybe they can make clogging inside the pipes. So yeah, the pump pumped, but we created clogging inside the pipes. So in this situation, the grinder will be a better solution. But if I have good diameters, then we can go with the non-clog very well. So this is like general looking how we can distinguish between different types of submersible pumps and how they work, how they do their work, and what's the difference. Here, submersible pumps could be installed in, let us say, there is wet installation and there is dry installation. What we mean by wet installation? Wet installation, as we see here in the left, the pump is submerged on the pump liquid. The same liquid which we are pumping, we submerge the pump there. This is what we call the wet installation. The dry installation, we are pumping sewage, but the pump is not submerged. As you can see, the pit wall is here. We took a pipe to the pump and we are pumping to out. Okay, we are pumping to out. This is the dry installation. Now, submersible pumps, all submersible pumps are designed to work in wet installation, but not all of them are suitable for dry installation. If you want to use it in dry installation, the manufacturer has to tell you this clearly. The manufacturer has to tell you that my submersible pump is suitable for dry installation. And usually they say it, okay? They will tell you if it's this, if your submersible pump is for wet installation or dry installation. They mention it clearly. Because submersible pump to work in dry installation, it has to have a good and special cooling system. The pump, the submersible pumps, once they are submerged, they depend on the surrounding liquid in cooling, which means the heat will dissipate to the pumped liquid, so we keep the motor cool. But once you put it in dry installation, the motor is closed, so how we can cool it? So then we need to equip this pump, I mean the manufacturer will do that, with something we call the cooling jacket. Cooling jacket, just to show you, looks like this. This is a cooling jacket. You can see this is the wall of the motor, and this is like external cover, and there is a cooling liquid inside surrounding the motor. Okay, why? This is to make the cooling, to provide good cooling for our motors. Now, by the way, before I forgot, sometimes we need this cooling jacket to be used with the wet installation pumps. When sometimes the pumps which has, for example, 400 horsepower, it's big size, maybe the surrounding liquid will not be enough to provide the cooling, so we'll need a cooling jacket, or the pumped liquid has high temperature, above 50 Celsius, so maybe we need a cooling jacket. Sometimes, because look, once you have submersible pump in wet installation, if you are depending, or the pump is depending on the surrounding liquid, then we need to make sure that the water shall not, the motor shall not be revealed. Okay, I pump the liquid till reach the head of the motor, then I will stop pumping. Why? Because these motors must not be uncovered by the liquid, because they need this liquid for cooling. But if there is a must to emptify this pit completely, and for example, if I need to emptify it to this level, I need long time to remove all this liquid from here to here, then you need a cooling jacket, even if it's with installation. Okay? If 1 minute, for example, it's okay. You don't need a cooling jacket. But if you need longer time to emptify, then you need a cooling jacket. Otherwise, keep the pump submerged, the motor submerged. Now, let us come for this question. Why submersible pumps have low hydraulic and volumetric efficiency? And here I'm talking about efficiencies, the volumetric efficiency, not on the overall efficiency. Now, to give you an idea, submersible pumps, usually the efficiency is between 20 to 62%. I'm talking here about the best efficiency point. Okay? I mean, some pumps as a best efficiency is 20-22. Some of them, they can reach to 62%. Okay? I'm talking here about the best efficiency point level for the pumps. So generally, it's lower than the clean water pumps. And this efficiency also could be different depending on the selection on your duty point. For example, if you can see here two curves, they are for the same pump. These curves are typical. But if you selected the pump for this duty point, which is here 25 liters per second at head 45 almost, you can reach, in this way, you can reach the best efficiency point, which is for this pump, which is vortex pump, 41%. 41%. But if you use the same pump, which has best efficiency 41, but you was pumping 10 liters per second at head 67 meter, then the efficiency which you will get is 32%, not 41. Let us answer our question. So why submersible pumps? What's the reason behind this lowering in efficiency for submersible pumps? Now here we will focus on the reasons which is exclusive for the submersible pumps. Why? Because generally any pump, even for the clean water pumps, there is some reasons which will lower the efficiency. Okay? We cannot, there is no pump has 100% efficiency or 90%. You cannot find. Why? Because even for the pumps which has which is working for clean water, any surface typical pump, there is some reasons which can lower the efficiency. For example, the diameters will change between the inlet and the impeller inlet. There is friction loss inside the impeller, friction with the casing walls. There is some turbulence of water. There is some bubbles, whatever. All these reasons, they will lower the efficiency of the pump. But for submersible pumps, let me see, they have some extra reasons. Same reasons they have, but they have also some extra reason related to the internal design of these pumps, which we'll see now by one. But before going to this description, I need to give you a small remark. I'm asking, is the solid content of the pumped liquid one of the reasons for lowering efficiency or not? The answer is, look, if you open any catalog for the submersible pumps, any catalogs for submersible pumps, and you see the pump curve like this is pump curve efficiency, okay? This curve is not showing lower efficiency because there is particles with the liquid. No, because these curves are made for the submersible pumps when they were pumping a clean water. So they took the submersible pump, the wastewater submersible pump, they took it and they were pumping a clean water, so they found this efficiency curve. So the efficiency curve is based on clean water scenario without particles. Now, again, for the types, let us explore the internal design, how it affects and lowers the efficiency of the submersible pumps. For example, the non-clog pumps, as we said before, there is big distance, there is big passage in the impeller. So this big passage lowers the ability of the pump to control this liquid, and also gives higher possibility for the turbulence of water. These things will lower the efficiency. This is like a negative consequence of this design, but we cannot avoid it. We need it because we want to pump wastewater. The second, also, the number of vanes for the impeller. In this kind of non-clog pumps, generally there is one vane or two or three vanes as a maximum. Once you lower the number of the vane, this will be one of the reasons that lowers the efficiency. But we cannot increase the number of vanes because this will affect the ability of the pump to pump bigger sizes of solids. Once you increase the number of vanes, then you have to make the particles smaller that you can pump, because the passage inside the impeller becomes smaller. Okay, so these are like technical design reasons for the efficiency to be lowered in non-clog submersible pumps. What about the vortex? As we said before, vortex, the efficiency becomes lower than the non-clog. The reason, because of this big gap between the inlet and the impeller, and we are depending actually on the vortex effect in pumping. This cannot help the pump to increase the efficiency. Actually, it decreases the efficiency. But for us, it's like a way that helps the pump to pump the waste without clogging. So there is a penalty for this, which is lowering the efficiency. What about the grinder? Also the grinder. We are spending part of the energy which has the pump in cutting, right? We are using part of the energy in cutting. So definitely there is part of the energy is wasted in grinding. And also behind this grinder, there is a screen holes So this also makes some resistance. So it can be one of the reasons which will lower the efficiency of the pump. So what we said before again was technical design reasons why the submersible pumps has lower efficiency than rest of the types of pumps in the world. So this is why, gentlemen, we cannot, for example, put in our designs, or sometimes we read in specs, they need submersible pump for wastewater, but efficiency has not to be less than 70%. This is not a realistic reason, not a realistic specs. And then we always face problems in compliance and waste of time for looking for some pump which we will not find in that can achieve such high efficiency in submersible pumps. That cannot be. Or for example, looking for a vortex pump that has efficiency 60%. This is also not realistic. This is why we are trying to explain this. Now, sometimes the actual efficiency is lower, becomes lower, okay, than we expected. And that one could be because of impractical duty point. What do I mean by impractical? The biggest challenge for submersible pumps always is how to increase the head, not the flow. You know, each 1 meter head you request from the pump is a big task for submersible pumps. Why? Because, as we said, because of these big clearances inside these pumps, it's each 1 meter head costs the pump a bigger effort, and it needs higher energy difference in design. Each 1 meter head, it's a big task for the submersible pumps. This is one thing. So that leads us to another point, which is when you ask for high head for small flow, it's something very challenging in submersible pumps. Very easy in water normal surface pumps, but it's very critical for submersible pumps. For example, when somebody is looking for 2 liters per second at 35 meter head, this is the best thing yet that you can find. This is a submersible pump. You can see your duty point is the beginning of the curve. This is the best thing you can find ever in submersible pumps. You cannot get the best efficiency point. You are so far from the best efficiency point. You are so far. You cannot find it with any supplier. But this duty point, 2 liters per second at 35 meter head, it's easy to find in best efficiency for clean water surface pumps. But submersible pumps, this is very challenging task. And once you find, you will find it at the beginning of the curve. So this is also one of the reasons. Then you will be surprised. Oh, let us see what's the efficiency here. Look for this duty point. You can see the efficiency is around 10%. 10%. Unfortunately, this is the best thing which you can find for this duty point. Now, some people maybe will be surprised if I told them, in many cases, once I see the duty point 35 millimeters, 35 meter head, unfortunately, in many cases, the actual head is less than that number. But the problem comes because people, they put high safety margin during head calculations. For example, he makes calculation. He found the head is 12 meters. So what he will do, he will say, okay, let us put safety margin 1 bar. So the pump becomes 22-meter head. Again, this is big, very huge safety margin. And as we said, for submersible pump, each 1 meter head, it's a challenge. Each additional 1 meter head is a challenging. So imagine you are adding 10 meters and it's a safety margin. So then you will start to find a selection for very big pumps, and maybe it's not also realistic. So you will find that later your pump is working at the end of the curve. Sometimes the problems comes from ignoring the static head. In submersible application, mostly, for example, the total head, if it's like, as we can see here, if your total head is 15 meters, mostly, if you make a breakdown, you will find the bigger part of this total head actually is a static head, And if you want to make selection, you have to put in the software selection, you have to mention and specify the static head. If you ignore it, you will go to the wrong selection. Look to this curve. For the pump, it's 4 liters per second, and the head is 15-meter head. And the static is 10. If you ignore it, the pump system curve will be like this. So this is the intersect. This is where the pump will work. So maybe you will think it's okay. But unfortunately, my friend, if you implement or enter the value of the static, the same pump, you will find the curve system will intersect with the pump curve at the end. So the pump is in the overload region. So please be careful. Don't ignore the static head when you are making selection for submersible pump or any pump, but submersible pump. Sometimes this leads for a wrong selection. Now, there is other things that lowers the overall efficiency. Okay, I'm talking here about overall efficiency. Before we said about things which lowers the hydraulic efficiency, but now there is other reasons I want to let you know about it that lowers the overall efficiency, including the motor power. For example, the cooling system of the pump. Once you have, for example, some types of the pumps which are using the cooling jacket, they have internally, not always, sometimes they have internally like small impeller. This is like specific. It's not the same impeller of the pump. It's like internal impeller specific for the cooling liquid to make circulation for it. So this, of course, will consume part of the pump power in rotating or circulating the cooling liquid. So this could be a source of lowering of the efficiency, but we need it. But to give you also an idea how the submersible pumps are cooled generally. Most of the submersible pumps are like the middle one. The motor, as you can see here, is closed. So it depends on the surrounding liquid to cool the motor. And also, it depends on the heat exchange that happens between the pumped liquid inside the volute and the motor side. Because you can see here the thickness of the outer housing of the motor becomes thicker from bottom. This also helps the heat to go to down here, and the water which is pumped, because it touches that surface, so some heat exchange will happen, and this helps to cool the motor. Other pumps are using the cooling jacket, and other types of pumps, like we can see here for dewatering pumps mostly, those they suck the water from here, from the bottom, and they allow the water to go move around the motor, and the discharge is on the top. It's like the pump liquid is forced to move around the surface of motor and going to the top. So in this way, we cool the motor. Now, there is another reason that in many submersible pumps, we can lower the overall efficiency because of the mechanical seals. Generally, the mechanical seal in any pump in the world, it consumes some of the power, pump power, because of the friction. Now, most of the submersible pumps, they have actually dual mechanical seals or two mechanical seals, okay? But anyway, so we don't have only one plane of friction. Now we have two places of friction, because once it's dual or two mechanical seals, that means I have friction here and friction here. So that means higher also consumption of power. Generally, these dual mechanical seals, they have their own chamber, and there is a sealing liquid, which is mostly the oil. This oil helps to cool these mechanical seals without the need for the pumped liquid, which contains impurities and particles, to cool these sealings. We need the sealings to be cooled by this their oil. We don't want the dirty water to go there to cool the seals, because if they went there, these solids can destroy and broken the sealing parts. Some types, of course, all pumps, they have bearings, and especially submersible pumps. Most of the submersible pumps, they have, or they are equipped with ball bearings. And ball bearings, generally, there is a friction inside, but it's the minor. But some types of submersible pumps, especially the big ones, which they have very big radial forces inside, they use the cylindrical type of bearings. And the cylindrical type of bearings, they have higher friction level than the ball bearings. So it's like extra source of losing energy. So all these things could affect the overall efficiency of the submersible pumps. So again, these are let me say, like the session of today to discuss the wastewater pumps, submersible pumps specifically, and how they are working. Because, by the way, there is a wastewater pumps, but they are not submersible. We didn't talk about it today, but this is our general idea about wastewater submersible pumps. As we discussed, we need to take a look about the type of wastewater for each pump during selection. And we were talking also about the types of submersibles, that they are different philosophy, how they are pumping the dirty water. There is the free passage and there is the grinder. The free passage, there is non-clog, there is vortex, and the grinding, there is with the grinder, and there is cutter impeller. There is differences. We said the highest efficiency comes with the non-clog pumps. The most pumps which is safer of clogging is the vortex, but unfortunately their efficiency is the lowest. And the grinders, they are specific range of submersible pumps, and mostly we are using them or we need them when the piping of the sewage system is has small diameters. So this is why we need to grind these particles, but it's not a mandatory always any sewage system to be with a grinder. And then we are talking about why the efficiency in submersible pumps is lower than other pumps, and we said they have their own reasons, mostly because of their design. Why? Because they need special design to be capable to pump dirty liquids. So this is what we have for today. Now I can open the time for your questions and comments. So all of you, you are most welcome to ask for anything.
Hi, Omar. How are you?
Yeah, how are you?
Omar, again, what is the type of the material used for the impellers for sewage pumps?
Very good question. Usually, let me say the most typical, it's the pump to have a pump cast iron casing with cast iron impeller, or ductile iron with ductile iron impeller. Both of them are cast iron. This is the most common. Now, for small pumps, for housing, you will see the stainless steel is more popular. But this is not because it's a stainless steel, because we need the stainless steel, but for very small submersible pumps, if you want to make it encasted, it will be heavier, and we don't need for that. So we can use sheeted submersible pumps with sheets, and these sheets cannot be made of casted material. So these sheets will go with the stainless steel, because we want this the thickness very small. This is for small pumps, but originally we go with cast iron, heavier, thicker surface, and this is more suitable for the residential and commercial wastewater. Why?
The reason,
the wastewater in this application, the residential and commercial, usually the oxygen content is very limited, and the pH doesn't go usually below PA6, and the temperature is almost it's cold liquid. So this suits the cast iron, and it matches with its economical value, and also the cast iron is very heavy, because the sewage is something weak, it's not something hard. But if you want to use submersible pump, and you know for example, I use it in applications like I'm pumping water with stones. If the stones is the most popular in that liquid, in this situation, I cannot use the cast iron or ductile iron. I will go to something called hard iron, or a nickel hard iron, Ni hard, or I can go for high grade of stainless steel. If my sewage is industrial with very low pH, some industrial wastewater, the pH can go down up to pH 2. This low pH degree, I cannot use the cast iron or ductile iron or hard iron with them, because it will be corroded quickly. In these cases, I have to go to the super duplex stainless steel, not duplex, super duplex stainless steel or higher grades. If I want to use a submersible pump to use seawater, of course, I cannot use the cast iron. I cannot use the stainless steel 316 or 3404. I cannot use all these materials. I can use super duplex stainless steel or nickel, aluminum, bronze, or bronze, complete bronze wastewater pump. Okay, this is for seawater, which is mostly clean water, but it's a seawater. It's a very corrosive liquid. So if I'm going to use the pump for some big stations for stormwater, then I can use cast iron casing, but with stainless steel impeller. Okay.
شكرا عمر. والسؤال الثاني, the second question is about the discharge pipe from the submersible pumps. Usually, we know that the pumps will work one duty and one standby. And we are sizing the pipe according to one duty. But some consultants were asking us for the case that the two pumps will work in sudden case together. So they are asking us to calculate the pressure drop according to according to two pumps working in duty. So I think this is a mistake, but I wanted to be sure 100% from your side.
Let me say, I will not say mistake or not, but I will tell you what we need to be careful of it so we can avoid any problems. Now, if they for us, if you want to size the pipe, one or for two pumps, the most important for us, what will be the speed of the liquid inside the pump? And I'm talking about speed, not the flow, which means meter per second. Why? Because if the liquid inside the pump must not be less than 0.6 meter per second in any way. Okay? So if you go below this speed, 0.6 meter per second, unfortunately, the water cannot have the capability to carry these solids. So the water will drop all solids inside the pump, the pipe, and then there will be a clogging in the future. So sizing the pipe depends on the speed, which must be not to be less than 0.6. And also, it's not preferred to be higher than 1.5 meter per second. So the sizing has to be in the middle, in between. Okay, this is first criteria for sizing the piping. The second thing, if there is a scenario for operation one pump or two pumps, when I do a selection, I should not depend in curve one pump only. I have to see this is the curve of one pump, and this is the curve will be for two pumps working together. Then I have to see the system curve. System curve will be like this. I have to make sure that there is an intersect between the curve of single pump and the two pumps. Because if the system curve was like this, the green one, this is the mistake. This will be the problem. Why? Because if the two pumps work together, you have no problem. But if one pump, if you used only one pump, then of course there is a problem. Why? There is no intersect between the system curve and the pump curve. So the pump will work, but it will be overloaded. You will notice the overload will make trip. Unfortunately, sometimes people, when they see this trip, you know what they do? they put some wood piece or something below the overload to stop tripping. And what will happen? The pump will be burned. So again, for single or dual pumps working together, for us, if the sizing cares about this speed limit of the sewage, not less than 0.6, it's not preferred to go higher than 1.5, we are okay with this pipe sizing. And second thing, we need to see the intersect between the system curve with the single pump curve or the two pumps curve. We have to make sure that there is intersect between the two curves, like we see here, here and here. If we satisfy these two conditions, we are okay. If you used one pump or you used two pumps together. Okay.
Omar, my question was, because it is one duty usual and the second is standby. They are considering that the standby for sure will stop. But as I know in the higher alarm level, that both pumps will work. Am I right or wrong?
This is something depends on the control design, because sometimes we can make it one duty, one standby, and there is no option to work together. This is possible. But the most common practice these days is they make an emergency scenario that usually one pump works. But if it's not enough or has some problems or there is some flooding, the water which comes to the pit is higher than what we can pump, then we have emergency scenario. So the two pumps will work because of this high demand. Okay. In this situation, we need to be careful. This pipe, once we size it for the worst case scenario. Okay, which is the two pumps. But I need to check after sizing that what about if I operated one pump? Is there a problem? For example, if I made sizing and for two pumps, for example, and I found the pipe has to be 4 inches. Okay. Why? If you found it like this, if you found that to work two pumps in parallel, I need 4 inches, for example, then I will check, okay, but if one pump works, what will be the speed of the liquid? If it's less than 0.6, then I must change the pipe to be 3 inches. Why? Because I want to avoid this. This lower limit is more critical. And after that, when I make this selection, I need to check these two intersects to be achieved. I don't know if I give you proper answer or not.
Yes, you gave me the proper answer now, Mr. Lamah. Thank you very much.
Most welcome,
but
Mr.
the last question is for the I was the same thing in the discussion for the impellers. They are telling some consultants are telling that the sewage, our sewage from our houses, containing chlorine for cleaning, containing acids, cleaning acids, and those things that the people throw inside the sewer system. So this will affect the impeller. But you told that the normal sewer is pH is 2 and below 2. So how is come like this?
I will tell you. What I said, this is like general. This is what people found in many tests, global tests for many manufacturers on the residential waste. Now, yes, people, they can use some Chlorix flash, for example, it's not acidic. okay, at the beginning. So it rises the pH degree. But how much they are putting chloride, for example? How much? It's a small amount compared to these pits, right? So actually, these kind of liquids which we are using, they cannot decrease the pH. Besides, the cleaning material, for example, which we use for clothes washing, like Ariel or the soap, these things are alkaline. They are not acidic. So actually, these things increases the pH. Got my
Yes, I
point?
understand it now. I got it. Thank you very much. Shukran, Omar.
Afwan.
Mr. Omar,
Yes.
regarding the text, so is non-cloth type needs submersible pump. Okay. In case this one, it is not covered, it is covered in non-cloth type. We can use also this vortex type.
Yes, it's like option. You can use non-clog, you can use vortex.
It's okay. But only the efficiency, only the difference.
Efficiency, it's the major difference. Non-clog are better. And frankly speaking, I didn't face any problems with the non-clog. I'm working in pumps 20 years, but I haven't seen problems with the non-clog specifically. And the efficiency is better with the non-clog. But also vortex, they are more safer of clogging, you know. But the probability, it's not that much big issue.
Okay, thank you.
Most welcome. If there is any questions.
Omar, shukran كثير.
Afwan. Anyway, gentlemen, if you remembered anything or you have any question, you can, I will write here my mobile number. You can call me or text me on WhatsApp, what suits you. This is 050. Sorry, I'm writing with using my mouse, so it's not that nice typing. 319 and 33 71. This is my mobile number and WhatsApp number. If you remembered any question or any clarification you need, or sometimes some documents or scientific articles, I will be very glad to share it with you. Most welcome, Mr. Napoleon.
يلا يسعد مساك عمر. شكرا لك.
الله يسلمك بالخير. الله يبارك فيك. Thank you for everyone. Thank you very much. Wish you have a nice day. See you next time in next sessions. Bye bye.
Thank you very much.
Bye bye.